But it says if a to the n equals b, then a is an nth root of b. And we spend a lot of time talking about square roots, and you don't usually do much else besides square roots until you get into Algebra 2. But you can take any root, right? So I kind of just wrote a couple examples here just to kind of give you the lingo here. But since negative 3 to the fourth power is 81, we can say that negative 3 is a fourth root of 81. And if we were going to write that, you could write it like this. The fourth root of 81, right? The fourth root of 81. One of them could be negative 3. I don't like that. It's negative. Right? And this one is the one we're the most familiar with. Because 4 squared equals 16, we can say that 4 is a square root of 16. And so that's why we don't put the 2 on a square root, because it's the one that we use the most often. We know that it's a 2 there, but any other root we actually put the little number out there, right? And so in Algebra 2, we kind of built you up to this. Like the first day that you did this, everything worked out nice. Like they were all perfect roots, and they all gave you nice numbers. We're skipping that today. We're going to pretty much get right into the ones that are not perfect roots and that we have to break up and simplify. I know. I think I wrote one more here. Yeah. You don't have to write that one. But we could say cube root, square root, and cube root. Everything else we say fourth root, fifth root, 10th root if you wanted to. But just to give you here, this is called the index, that root there. So if it's a cube root, then the index is 3. What's under the radical, that number is called the radicand. Tomorrow I'll give you, what's that boy that wrote the joke? I'm not sure I gave it to you. What's his name? Arnold, something Arnold. J. He radicand it. That's where that comes from. He wrote me a joke and had this word in it, and if you didn't know what it means, then you don't get the joke. I knew what it meant, and I still didn't get the joke. But yeah, this is the radical sign. Because I didn't know what rattle canned meant, so that was my problem. I didn't know that that meant spray paint. I knew what radicand meant. He wrote me a joke, and it's very much written. I have not. How's he doing? Oh, yeah. He looks like Duck Dynasty. He growing out the beard. Okay, everybody okay with this? Let's get into what we're doing today. All right, so I am starting you off kind of nice, I guess, with a nice one, and then we'll do one that's not so nice. Remember when we solve an equation and we take the square root of both sides and put plus or minus? But when you're doing these problems, you take the sign that's there. Sometimes they give you a problem like this where the plus or minus is in front of it, and you're going to keep that plus or minus there. But if there's no sign in front of it, you just take the positive root. We call that the principal root. Sometimes they put a negative in front of it, but you do what's there. But this one is a square root, and it works out really nice. The square root of 16 is 4. And what about the square root of x to the 6? How do you do that? Yeah, it's kind of a, think about there's a little index here of 2, and what you're asking yourself is, if you had the square root of x squared, do you agree that those just cancel out and you get x out of it? So when you're doing this, you want to ask yourself, how many x squareds are in x to the 6th? Or as Nathan said, you can just take this number divided by this number if it goes in nicely, and you agree that there are 3 x squareds in x to the 6th? You could write that as x squared times x squared times x squared. And the square root of each one of those would be x times x times x, or that's just x to the 3rd. Yes?
So we just have to divide that. We don't have to actually.
Well, you just have to take the square root of it, however you're going to do it. Whether you do the little shortcut here when it works out nicely, or whether that you think about it as the square root of x squared is x times x times x, and then you put it back together. Right?
But if you were to times all 3 of those together, would that get me?
No, because you add, right? When we multiply, we add. That works out really nice because it's a perfect square. But what we're going to focus on are the ones that don't work out so nice. Let's see if I put a nice one up here. Oh, yeah. We could do the same thing with any root, not just square root. So it's really important that you pay attention to the index. So this one says the fifth root of 243, a to the 10th, b to the 15th. The number part today might be the part that you struggle with the most. The fifth root of 243, I don't know what it is off the top of my head, but if it works out nicely, you can do that on your calculator, right? Like you have that, right above the caret button, if you hit second, it looks like this. Right, that button. Square root button that has its own button, but for any other root, you have to use this button, and you have to do the root first. So you have to hit 5, then you hit that button, and then you type in the number. And if it's a perfect power, like if 243 is something to the fifth power, it'll give you a nice answer. If it gives you a decimal, don't write that decimal down because that's never going to be the right answer. And what does it give you? 3? So the fifth root of 243, that's just 3. What about a to the 10th? Now we want to know perfect powers of 5. So how many a to the 5ths could I write out of a to the 10th? 2 of them, and I'm going to write it underneath here if you want. Like this would be like a to the 5th and a to the 5th, because the 5th root of a to the 5th is just going to equal a, right? That's why we always write them as the power of whatever the index is. Or Nathan says you can just divide it out, which works. 10 divided by 5 gives you 2. And how many b to the 5ths are in b to the 15th? 3 of them, because you could write b to the 5th, b to the 5th, b to the 5th. Take the 5th root and you get b times b times b, or b to the 3rd. And that's your answer. How do you feel about that? Maybe vague memories of that? I do want to throw in the one on your homework from yesterday that asked you to take the square root of that negative number squared, and there was some confusion on that, is because that technically speaking, when you take the square root or any even root of a number, you really should put some absolute value bars around it. We don't really push that a lot in Algebra 2, but I do want to at least share with you why that's true. Oh wait, just kidding. We have to do this one first. I wish I had clickers and you could all like buzz in here. I'm supposed to get some, but try this one. Don't yell it out, but think about whether you would pick A, B, C, or D. I know they're supposed to give them to me. I know. I got an email that said Miss King was going to give me her clicker, but then I'm not enough. But you all get a clicker with a number on it, and then I say buzz in with your answer, and then I push a button and it shows me how many people picked A, B, C, or D. And then on my separate sheet, I can see who actually said what. So like, if well, I don't think I have to show that because like, you know, I don't want to show that you picked the wrong answer. But then I can see what's happening there. But we can see like, do we get it or not? So what do you think? Yeah. The fifth root of x to the 5th is definitely x. The fifth root of y to the 10th, there's 2 of them in there, so it's definitely xy squared. So it can't be C or D, right? And A, you got to take the sign that's in front of it. Since there's not a plus or minus out in front, you got to take just the positive root. With me on that? So don't add a plus or minus if there's not a plus or minus. I didn't number that one, so it might throw you all off now. If you numbered it. Did you number it? Just erase it then. Because my next one is numbered the next one from here. I don't know why I didn't number it. I apologize. Alright. This one's really easy, but I want to talk to you about this whole negative even power thing. What would the 6th root of t to the 6th be? Would be t, right? But technically speaking, you should say the absolute value of t there. And I'm going to let you read this, and then we'll kind of talk about it. You don't have to write this paragraph down, but I just want to note it for you, right? So I'll be quiet for a minute. What? Yes. Go back again. If I remember to put it on YouTube, I totally forgot to put the notes down yesterday. And Bryce went home and looked for them, and they weren't there. And then I realized at about 7 o'clock last night that I forgot to put them on, but I don't have them with me at home like I have to here. And and then I just couldn't do it, and I was feeling very guilty. But I wrote a note today on my computer. So every day, hopefully, I will see that note for them on there. Okay, so here's the big thing. If you take an even root, so if the index is even, you really have to show that you're not going to have a negative number under there. So to do that, we say the absolute value. So the technical answer here is the absolute value of t. Am I going to mark it wrong if you just put t and not the absolute value of t? I'm not. When would it come into play if it's a multiple choice question and they gave you choices that was absolute value? I don't think the Ivy Tech test is multiple choice. I'm pretty sure it's not multiple choice, but that's where it comes into play. In Algebra 2, that's where it came into play. But you really have to say that, because what if t equals -1, you kind of have a problem to say that your answer is -1. And that was the one yesterday. Remember that we did that was like the square root of, I don't even remember what it was, but something like this. People wanted to say that the answer was -4. The answer is 4 because technically you're taking the absolute value of what's under there, so that if there was a negative number, that you would get a positive. If it's an odd indexes are allowed to be negative, but even indexes are not. And so as you check your answers in the back of the book today, you might notice some absolute value bars. I just wanted to explain it to you so that you knew where they came from. Okay? All right. Let's get to the good stuff here. Most things we deal with are not perfect roots. And so we can use the product property and the quotient property to simplify or break up our square roots, which I know that you've done before. Square roots we usually do the best with because we've done those the most, but other powers people struggle with a little bit, so we're going to make sure that we work on those. So, product and quotient. You can never break up addition and subtraction under a radical, but you can break up a product. And it just breaks up as the nth root of each one of those times each other. And the same thing goes for if you have a fraction. You can take the nth root of the top and the nth root of the bottom. And that's going to help us as we simplify a few of these. So we're just going to kind of do a bunch of examples. And then towards the end, we're going to add radicals and multiply radicals and lots of fun stuff. Again, kind of a review of some stuff you did in Algebra 2. Everybody okay with this? Starting slow here. If it's a perfect square, you still can just take the perfect square, since this is even a number of two things here, the same way we always have. But if it's not a perfect square, you have to simplify it. You have to say, how many perfect squares can I take out? And anything that's not a perfect square, I'm going to leave back under the radical, right? So I started off with this one. It's kind of nice. And I'm going to kind of show a lot of work on this. But the square root of 25, is that a perfect square? Yeah, so I'm just going to leave it under this for now. You can go ahead and say 5 if you want, just to show you. I'm just showing you my breaking up part here. What about a to the 4th? Is that a perfect square? Yeah, because it's even, so I can leave it as a to the 4th. What about b to the 9th? Can I take the square root of b to the 9th? I can, but I can't just work it out like, I can't just say 4 divided by 2 is 2, right? So you have to break that up into a perfect square and what's left over. So what if I wrote this as the square root of b to the 8th and then an extra b left over? Is that the same as b to the 9th? Yeah. And you should be able to take the square root of b to the 8th because it goes into the index evenly. Like you always want to be divisible by the index that's over there. So you're going to have stuff that's out in front of the radical that works out nicely, and then you're going to have stuff that's left over underneath it. And like I said, this one worked out pretty nice. I'm going to go through and take the square root of everything that worked out nice. So I get 5. And what would the square root of a to the 4th be? Yeah, how many a squared are in a to the 4th? There's 2 of them. And the square root of b to the 8th would be b to the 4th. But I cannot take the square root of b, so I leave it as the square root of b. Do you have memories of this from Algebra 2 class? works for all powers. And so if you forget what cube roots are, then you can use your calculator to help you a little bit. But the letter part is the same. You just want to make sure that the index divides into the exponent, and anything that doesn't is left over. And again, this one's very similar to number 4, except for it's a cube root now. But I believe you can take the cube root of 125, because it's 5 times 5 times 5. And what about m to the 30th? Can I take the cube root of m to the 30th? Yeah, because 30 divides into 3, so that's how I know that it works. $20 does not divide into 3. So what you want to think about is, what's the biggest number that divides into 3 out of 20? 18, right? So I'm going to write that as the cube root of p to the 18th. And how many do I have left over? 2, because 18 plus 2 is 20. And again, if you don't show this step, I'm okay with it. I just like in your notes to give you like an idea of where this is coming from. So everything that's a perfect cube, I can bring down and work it out. So that's a 5. The cube root of m to the 30th, there's 10 of those in there. And there's 6. 18 divided by 3 is 6. But I cannot take the cube root of p squared, so I'm going to have that left over. You should never have an exponent left under your radical that's equal to or bigger than your index, because if you did, you could always take it out. Like think about if you have p to the 3rd there, you could take the cube root of that. So that's the kind of way to check that you simplified it correctly. Questions about that? What about if I gave you something like this? What? So this one is 2 different square roots multiplied times each other, right? There's nothing in between there, but you can put a little times sign if you want. And it's a square root of 2ab squared times the square root of 6a cubed b squared. And for the most part, looking at either one of those, do you agree there's not much you can simplify right now? Like a to the 3rd is the only thing, well, I guess a b squared, like I can't really do a whole lot. So just like you can break up a radical, sometimes it makes sense to multiply it together first before you simplify it. So you can multiply radicals together if they have the same index. You're just going to multiply the numbers and the letters underneath it, and then maybe we can simplify a little bit better. So I can say that 2 times 6, I'm going to get a 12 underneath that radical. A times a to the 3rd, remember we're adding those exponents, so that's a to the 4th. And b squared is b to the 4th. Yes? And now we can break it down, and usually you can get more out of it by doing it this way. Square root of 12 is not a perfect square number. Do not ever give me a decimal on these problems. I want you to simplify it. So can we break 12 up as 2 numbers, 1 being a perfect square? Yeah, and hopefully you kind of have memories of that from the quadratic formula stuff. But I could write that as the square root of 4 times the square root of 3. Just like we do with the letters, you write it as a perfect square and what is left over. And this worked out really nice with my letters, because now I can take the square root of both of those. Do you agree with that? Make sure you write what's outside the radical in front, and then you write your radical at the end. Otherwise, it gets a little messy when you're grading it. So I like to go through and write everything that's a perfect square. Perfect square, square root of 4 is 2. That's taken care of. That's not a perfect square, so I'm going to skip it. The square root of a to the 4th is a squared, and the square root of b to the 4th is b squared. And then what's left over is a radical 3. And that would be your answer on that. So you see what you can do with this one. It's cube root, but see if you can multiply. And that 5 at the front is just a multiplication, which means it's just going to kind of come down with the problem until you take something out of the radical. So the 5 just kind of comes with it. So 5 times the cube root of 100a squared times the cube root of 10 squared. See if you can multiply and get that to simplify. None of them have fallen yet. It's been hanging on for a while. That one panel things. But yeah, they are going pretty well. And now we're back there. Respect.
Oh, yeah.
Yeah, good stuff. Should work out nice today. We should have nothing left under the radical, right? 100 times 10 is 1,000. And then a to the third. And the cube root of 1,000, a lot of people think that's not a perfect cube, but it is. 10 times 10 times 10 is 1,000. So that's the same as saying the cube root of 1,000 is 10. Why did I make that a 3? And then the cube root of a to the third is a. So I think you should just get 50a on that. Did you get that? Or on the way? What? I don't know. I just always use red. This is my teacher and I grade red. But look, I need to stop because look at the end point on this compared to the end of this marker. Because I always use red. Yes, you just have to multiply these first, and then this is just multiplication as well. So the 5. If the 5 wasn't in front of it, your answer would have just been 10a. But because the 5 was there. I know, I told myself every year I'm going to do this, and then I can just use green, and it'll still be red, but it makes me feel like it's not right to do that.
Wait,
Mhm.
what if it was like, there's another 5 at the other one?
You have to multiply 2.
Multiply that.
Yep, yep. So then that would be, so 250. Okay, yeah. All right. We can also add and subtract radicals. I always say treat it like a variable. So just like if they're the same variable, you just add them and you add the coefficient and you leave the variable alone. It's the same with radicals. So x plus x is 2x. Same thing with radicals. If it's the same radical, same index, radical 2 plus 2 is 2 radical 2. If they are not the same index or they are not the same radical, you cannot add them together. Like the square root of 2 plus the square root of 3, that's it. Like it's not the square root of 5. You cannot add those together. The square root of 2 plus the cube root of 2, you can't add those together because they're not the same index, even though they're the same number underneath. So they have to be exactly the same index, exactly the same radical, and then we can just add and subtract. We can also multiply with radicals. We'll go that out in a minute, but make sure you remember that rule on adding. You okay with that? So what about this good problem here? Three squared root of 45 minus 5 squared root of 80 plus 4 squared root of 20. The easy answer would be like, I can't do it because the radicals aren't the same, right? But we can simplify them first, right? So it's not as easy as saying, oh, that's it, that's my answer. What we're going to go through is we're going to simplify each one of these radicals. So you have to go through and think about what multiplies to give me each one of those radicals. Make sure you pick a perfect square. Like 15 times 3 gives you 45, but 15 is not a perfect square, and 3 is not a perfect square. So make sure you're picking a perfect square when you do this. So 45 would be, what would be your one? 9 and 5, right? I like to write them with radicals first, so I don't miss a radical somewhere that I should be doing. What about 80? 4 and 20 works, but you're going to still have to break 20 down, right? Which works. But if you think of that and you do 4 and 20, don't forget to break 20 down. I'm going to go ahead and break that down as 4 and 5, right? 16 would also go in that, but make sure you just break it down all the way. and then 20 would be 4 and 5. And notice, just like the last one, those numbers in front are just multiplication. They just kind of come down until you're at the end to simplify. And again, I know it's kind of easy to want to skip steps, but just make sure you don't get in too big of a hurry and make a mistake. I'm going to show lots of my work here. I'm going to go through and take the square roots. So that would be minus 5 times 2 times 2 square root of 5 plus 4 times 2 times square root of 5. So that would be 9 square root of 5 minus 20 square root of 5 plus 8 square root of 5. And it's not going to always work out so nicely, but this one worked out that they all have a square root of 5 on them now, which means we can actually simplify that by just taking 9 minus 20 plus 8, which I think is negative 3 square root of 5. And again, probably square roots are what we feel the most comfortable with, but you can do this with any root, right? Like if those were fourth roots, you would want to go through and think about what numbers to the fourth power would we need on there. So I think I have another one of these, maybe with some cube roots. I don't remember. Anyone have a question about that, where that's coming from? I'm almost done. What? Not anything easier. Oh no, just kidding. I just skipped the other ones. Let's just multiply. I was worried about having time, but we're actually okay on time. Yes. Oh, right. It's 3 times 45. If that was cube root of 45, if the 3 was up there, then you're right. That would be something totally different. All right, we also can multiply radicals. When you multiply radicals, you just multiply them and keep them under the radical. You multiply the numbers outside and keep them outside of it. So this one is foiling, right? If you have a binomial times a binomial, we just have to FOIL it out, and they get kind of messy, but it's just the same rules here that we've always been multiplying by. If I take this times this, right? I take the numbers on the outside times each other. 3 times 2 is 6. There's nothing to multiply that radical 5 by, so that just becomes 6 radical 5. Just like if it was 3x times 2, that would be 6x. You just multiply the numbers and bring the x down. You do the same thing with radicals. But when I take this times this, it's just 3 times nothing in front of that, which is just 1. So that's just a 3. Then radical 5 times radical 3, you multiply them and put them both under the radical. So radical 5 times radical 3 is radical 15. Same thing works if those were both cube roots. You can just multiply and keep it as a cube root. Then inside, negative 2 times 2 is negative 4. And then just bring down the square root of 3. And then the last one, negative 2 times 1 is negative 2. Radical 3 times radical 3 is radical 9. Make sure you simplify that if you can simplify it, right? So that actually is going to work out to be a nice number there. Sometimes you might have some like terms that you could put together. On this one we don't, but we could simplify this. So like my answer here would just be 6 radical 5 plus 3 radical 15 minus 4 radical 3. This would really be 2 times 3, which would be minus 6. And if you wanted to put that in front, you can. But we can't put any of these together because they are not the same radical. So adding and subtracting you cannot put together. Questions about that? I feel like I should have done more other power. This is R8, day 2, so we're back actually in section R8. You're going to do page 78, number 12 through 42, multiples of 3. Something like that. beginning examples. They're very helpful. So especially tonight, if you start working on that and you feel lost, we'll go over questions tomorrow like we always do. But you kind of want to start looking back at some examples in your book and seeing how that they kind of do some of that stuff. All right. So I will tell you number 12 that you're doing starts with the cube root of 54. The cube root of 54 is not a nice number, so you have to think of numbers that multiply to give you 54, one of them being a cube root, a perfect cube. So maybe it helps to think about perfect cube numbers first, right? So like in Algebra 2, you wrote all these out, but I'm not going to do it this time. But like 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, right? These are the numbers you're trying to come up with. Like, does 8 times something give me 54? Does 27 times something give me 54? So that's where doing stuff besides square roots can get a little tough, right? You with me on that? So, and if it's a fourth root, you're trying to think of fourth power number. So you might want to think about what's 2 to the fourth, what's 3 to the fourth. And that's what you're looking at on those problems.